Take on Everybody Codes Quest 13. Get my template ready. And that's about it. Let's see what Quest 13 has to offer. Never gonna... Wow, just got rickrolled. Boo. Okay, so we have our matrix, a grid, maybe some walls. Not a hex color, I don't believe that's in there. Ooh, a maze? Uh-oh, okay, so if we have a maze, we have some pathfinding to go on here. Paths and their time. So I see an S, I see an E. Okay, 36, 30, 28. The optimal path. This sounds like... What is this going to be, a Dijkstra? Platforms can be at 10 levels from 0 to 9. Both the ceiling and floor are portals. If you move to a platform up while on a 9, you'll be transferred to 0 via the portal. Down. Okay, what the heck? So don't look at hashes. Gotcha. So let's generate a world. Const world equals notes. Let on the new line that map line. Turn that into an array of strings, or characters rather. Shortest time, each change. Okay, so shortest path, there are weights. Forget exactly how Dijkstra does this. 36, 30, 28. Okay, yeah, this seems like out of the box Dijkstra. Just don't memorize it. So let me look at the difference here. Platforms be at 10 levels, so yeah, hashes we ignore. The ceiling and the floor are large portals. Try to move to... If you try to move a platform up while on level 9, you start on S with 0. You're trying to reach E. You can only move between platforms if they're on the same level, but changing the level of a platform takes time. Huh. Each platform disintegrates. You can only visit once at a time. Each level change takes 1 second. Okay. So it's the ones with the minimal difference. 5, 6, 7, 6, 5, 4, 3, 4, 5. Yeah, they each have a difference of 1. We have spent 5 seconds here, and then, of course, my freaking monitor wants to turn off. Okay, there we go. So this is basically 36, 30, 28. Let me make sure I can do that calculation. Come on, monitor. That calculation accurately. So it's from 0, 5, 0, 5, 0. Okay, so 5, 0, 5, 0, 5. Then back to a 0, right? Are the ends are at 0? Which is also at 0. So that is 0, that's 5, 10, 15, 25, 30, 35. Let's give more space here. Yeah. So I guess there's a 1 second cost somewhere. Moving from one to another also takes 1 second. Okay, so I spend 5 seconds getting this down, but then I send another moving to it. God, freaking monitor. Okay, so yeah, it's a little off by 1 there to fight there, but it shouldn't be too bad to figure out. Okay, this wanna be cool now? Oh, nope. Okay, that's not gonna work. Sorry, just fighting monitors. Yes, I think this is nice. Okay, that monitor is end of my limits. JavaScript. Gemini, not too bad. Okay, so I need to regenerate this from and to thing. With the weights, that should be what I'm looking for. Not implemented Dijkstra's in years. So const. Believe graph equals here. So for let r equals 0, r less than world.length, r plus plus. Do the same thing for columns. C, except we'll do world 0 length. And then we'll be able to build all of our movements. Cannot go back to a previous one. Okay, so const car equals world rc if car equals a hash, then ignore it. But if you're anything else, then you're getting added to the grid, or to the graph rather. So const key equals r plus c. Then yeah, it'll be from here to other places. So let's define that. So it's gonna be all 4 cardinal directions. So for ROCO of so 1 0, but it's an array of changes. So 1 0 minus 1 0 0 1 0 minus 1 const nr and c equals r plus ro, c plus co. Now we gotta make sure these are still in universe. Well, find the other car, const other car equals world rc, but new row, new column, optional chaining in case that's off. There we go. Now if it's invalid, so if not other car equals this, ignore, not make a constructor. Now we have that. We want to then say, great, we found somewhere for you to go. I'll go ahead and add this graph from key to other places. Now the trick will be adding the weights, which is the difference between their numbers. So that'll be const from level equals or car. So if car greater than equals 0 and car lesser equal to 9. Come on. Plus car otherwise 0 to handle the S and the E. Nice. And same thing up here. 2 level is other character. Otherwise it's 0, and then it's 2 level. Now I'm trying to remember how this works. Do they come to our level, or do we go to their level? You start on S, you reach E, you can only move between platforms on the same level, but changing the level of the platform takes time. Each platform moves up and down like an elevator. So I think the one you're standing on goes up to 5. Like in this one. So I go up to 5, then I go up to 9, then I go down to 7, then I go down to 4, down to 3. Oh, this is a neat little game, actually. Yeah, getting too far ahead of myself. Only change level platform you're currently on. Nice. So yeah, the difference is from where I am to where it is. Okay, so it's difference. Cost diff equals abs from, not abs from level minus 2 level. Well, really, it's the weight of this edge, I suppose. There you go. Now it's graph key from there to const other key and R plus and Z. Now other car, other key. And then we have the weight, and we don't need all these other things until we actually need them. Key value to level from level for the weight. Okay, so we have that. So in theory, I'll have me all the weights. Yeah, so 1-to-1 can get me these places. Let me look in my thing. 0, 1, 2. So 2, 0 can get me to 2, 1. That's what I want to look at. 2, 0 can get me to 2, 1 for a cost of 5. That's right. And 2, 1 can get me to 2, 0 for a cost of 5. And 2, 2 for a cost of 5. Yes, yes, yes. I love it. I love it. I love it. Okay, so now I don't have dice just memorized. So you're at the top for a good reason, hopefully. Light fame, we'll figure it out. Okay, yeah. Distances, visited, nodes. I'm starting to remember us. Start to infinity, the beginning to 0. Okay, distances from the start to every. Okay. I did generate the graph correctly. Good. I mean, I can just grab this if I wanted to. Probably wouldn't work. And I thought there's usually a heap in here, or a primary thing. Oh, they just have a dot sort call. Honestly, I'm just gonna grab this. Graph record of string to a record of string number start. I believe that is just string. Right, and this will return to me. Will this give me the path? The distances. Interesting. Okay, so it's not actually recording a history. I think that's sufficient. I can take the distances and, because I just need the seconds, and pull that out from it, and then I might need to add 1 for all the lengths. So let's generate instances by calling Dijkstra on the graph, starting at, where am I starting at? 0, 1, so it's 2, nope, 2, 0. There we go. And let's just see what these are. There we go. And I want to get to 2, 0, 1, 2, 3, 4, 5, 6. 2, 6, right? So that's 18. There's a little bit more. Well, actually, is it? No, 18. Actually, with how many changes there are, I think that counts. So I think my weights just all need to be +1, because the price of moving is 1. Yeah, so let's see. Costs. Well, let's actually get start and end as thing, because they're going to move. There we go. Now, as you find that and that, if it's a thing that if car equals s start equals rc, same thing for my end, but end, and now I can just put this in here as start r plus, what the heck, plus this plus. Not where my plus, start C, then it'll be const dist to end equals distances, well, end R plus end, not in code, C, and let's just see what we got going on here. I don't think we're gonna get that lucky. Okay, let's grab it. Imagine part 2 is where this is going to get real fun. Ooh, spaces. What are these spaces doing? Spaces are illegal. What do I do with spaces? I ignore spaces, right? Yeah, I ignore spaces. So if is this or car equals space, what do I do with spaces? I don't think spaces are technically not inside the maze, so they're like the void. But my algorithm, at least my graph generation, is not encountering that. So let's add support. Great, we're now ignoring spaces. Don't be infinite. That's a number. Could be the right number, could be the wrong number. Ah, dang it. So it's 3 digits. It is one something, be something, but not that. Okay. Put 1289 here. Okay, if I look at this with my eyes. Right, so we're doing a thing. If this is Dijkstra's, then it should just be working. But it's a not. So if my graph generation is wrong, we're doomed. Yeah, we're already handling voids. Let me add a dot trim on there since I just threw that in there. So the only difference here is that spaces were introduced. I mean, aside from it being different, the only difference is the spaces. Make sure this still works. It does. 171 is not the answer. Okay. Each level change takes 1 second. Move from one platform to another. So if there are no level changes, then you're not taking the extra second. So I added a second to everything, but that's not really true. So however way I fix this math isn't completely valid. So if I were to make one, the problem is I can't test this for real, but if I were to make a bunch of zeros, I'm trying to answer what this would be. Each level change, moving from one platform to another, takes an additional second. So would this be 1, 2, 3, 4? And I can't count. So moving. So I'm here. 1, 2, 3, 4, 5, 6 is a 6 seconds. If so, I don't think mine's gonna be 6 seconds. I lied. It is 6 seconds. Well, changing a platform should cost me a second. So did I end up on 28 the wrong way? Okay, so I need to check if the weights are the same. Well, if weight if weight equals 0, we do something else. Yes, it's a ternary. It's fine. We'll do the otherness. So if it is the same, then we're basically saying it takes you the 1 second. Otherwise, we're saying yes, spend time moving the platform, and it's going to take you the 1 second. Does that break this though? It does. It puts you at 38. My understanding is it takes us 5 seconds to move up. No, it takes us 1 second to move up, 1 second to move across. 1 up, 1 across, 1 up, 1 across, 1 down, 1 across, 1 down, all those. Wait a minute. Each level change takes a second. One from another takes a second. I don't like it. Why is this one failing? Why are they both failing? Oh, I had them in the same name. Example 2. What's on me there? Sure. Still give them the 171. log it. I don't think it's going to give me much to see here. Or not log, but rather look at it. Yeah, look at all these distances. They look great. Our end is 727, 171. Yeah. Yeah, 727, 26, 25. Got the previous one. Yeah, makes sense. I'm trying to think what would be the way for me to trace this path back using these. Is it literally just going from the end back to the beginning using the least ones? So I go from 127 to 126. From 126 I go 120 or 125. Yes, I guess it'd just be to my smallest neighbor. Sure. I could do that. I don't see that helping me because I don't know. That would help me validate an assumption if I had an assumption here. I ain't got no assumptions. Interesting. So it is working on the first one, though I can't validate it's working the way I want it to. So I do need to generate freaking monitor another path to basically be like, hey, are we making it through here or not? So I just need to add pathing to Dijkstra's. Let's get, nope, wrong one. Dijkstra's with path. Maybe Gemini will give me something good. Okay, it's all keeping track of the previous's and a cool thing. Yeah, what's the worst that could happen? Yeah, all my types are gone, but that should be fine. Graph, start node, great. Distances, previous nodes, sure, we'll pull that out. Previous nodes, and then I do this path, previous nodes, end node. Okay, so console log, get path, previous nodes, end node, which I have right here. Let's see if it's correct. We'll start with this one, since that's the one we know about. And the path, not on the world grid, but 202111. That is going up, then it's going down, then it's going low, then it's going back high, which is what I would anticipate. Let's just draw it on the actual world. For cost, what is this? You're an array, right? You don't tell me. Of P const RC equals node split on that splice. Split on this. Oh, come on. That map number with single digits. Oh yeah, that'll work. There, little multiple numbers will work there. World RC equals. I don't want to put an O there. Let's put a symbol that's not actually in our thing. Plus. There we go. It's good enough. Console log world dot map L dot join back up, and then dot join the world back up. And let's have a looky-loo there. Now, of course, I'm not going to see it because terminal outputs are going to avoid. Yeah, this is exactly what I would expect. The first line's pushing us off, but It's good. Yeah. And then, if I go to that one, I'd expect the same one here, because, well, I'd expect the straight line, because it'd be the straight line most effective. Okay, I guess I get to look at it on the real one. Again, I don't have an assumption to validate, so this isn't going to be a lot of value. Sure, we're avoiding 8s and 9s. I love it. I see us doing a route around that 9 in the top left. Is it really cheaper? Oh, because those 3 4s are all on the same level. Yeah, that's cheaper. And then you go to a 6, so instead of paying the price of 4, 5, 6, 7, 8, 9, going up by 5, and then down by 3, 5, 6, 7, 8. So instead of paying 8, you pay 1, 2, 3, 4, 5. Yeah, you definitely won there. That's cheaper to go around that way. So if my distance is right, my other thing is right, I could just be off by a 1, in which case my 1 low or too high. So it's 100 and something. We got that. So the thing is, it's giving me the right for the example, but I don't like, again, how it calculated it. Okay, let me manually math it through then. So we have this path. So it's 0, 5, 6, 7, 6, 5, 4, 3, 4, 5, 0. So this is 0 to 5. Let me add more spaces here. So these transition numbers, we're gonna need it. So this is gonna be 5, 5, and 6, because you need to move up to over to the 5, and now you're at 6. You need to go up to the 5, up to the 6, so that's 7, 8 to get across. I'm mathing this very wrongly. I think I put the calculation for this in the wrong place. The calculation for my extra weight should go in the actual dextrous. So yeah, distances between them equals distance plus 1. The movement is a price. And distance would be over here plus 1. Which means when my weight is 0, it's here. Otherwise, I think that, yeah. Okay, I broke it. What path are we generating, though? The downward path. Which is actually 30 seconds, not 38, so you got somewhere wrong there. Thing is, the distance to any neighbor is always at least 1, because you're moving through them. Okay, so I added it there. Was I supposed to do something else here? If weight is 0, then you have none. Otherwise, it's just the weight. I felt like I just moved the 1 to a different place, though, at this point. Yeah. I mean, if it generates a different number, maybe. No, it's the same number. Okay, I didn't really change anything. I just moved it around. Maybe I can use the path to generate what the weights are, or the distances are. Yeah, let's do that. P dot map. Okay, there we go. So 0, 6, right? 1 to get there. Oh, wow, that looks accurate. So they all are increasing by at least 1. Look at the last two, right? Going from 4 to 5, so it's 1 to move, 1 to go. 1 to move, 1 to go. 2 difference. Dang it. And then from 5 back to 0, it's 5 and then 1. 22, 4, 5, 6, right. Dang it. And the path that's generated here looks like what I'd expect it to be, unfortunately. I'm just gonna do some off by ones. Nope. Okay, let me look at the path. Exactly what I'd expect it to be. Okay, so let's see. We go on that first one, we stay on the left. Is that the best optimal? 6, 8, 3. So yeah, 2, 5, 5 versus going on that side, perhaps. Yeah, there's a lot of variance on both of them, to be honest. Okay. 6162. So a lot of changes there. It's cheaper to go down here, apparently. I mean, this bottom right range is definitely cheaper. And then we go up the left route, which is true. There's a big change here. Don't want to hit that. Go up and above the 9. Oh, it's a different one. We go through this because there's nothing to go up and above. We stay on the left. 3, 1, 7. Yeah, 1 and 7 are big changes. Down to the 2, another big change. We then stay on the bottom. 9, 6, 6, 8, 3, 6. Yeah, there's a lot of those changes on the 8s and 3 and the 6. So just 6, stay in the 6s, drop to 2s, 1, 5. We avoid that 8, you better do, yep. Then there's another 8, so we stay the 5 to the 7. Stay on all these, which looked good. More 8s, yes, avoid the 8s. And then we go here. So the starting and the ending are considered 5, right? Each can be visited only once, right? I haven't implemented that rule specifically. Well, they both start at level 0, apologies. Did I do that math right? And the rest are working. Right. Only move between platforms on the same level. Yeah, can't visit a single platform twice. I don't have that written. I don't think I need to have that written. But if I discover a shorter path to one, that would perfectly be valid, and the visualization is not even showing a double visit, so it seems right. Minimum number of seconds needed to complete your maze. Yeah, and our unit of weight measurement is seconds. Huh. I'm not seeing what it is I'm missing, especially for part 1. It's gotta be something real. I just realized it. I was reading back on a little, and I was like, oh, there's a freaking portal. So it's, you can go from the bottom to the top. So it's not from level to level, it's the least of from level to level or to level from level. This will be easier if I get into there. Let me in. Okay, so we're going from 6, come on, to 5. Why are you not running from me? Yes, so this can be going from 6 to 5 directionally, or it can be going the other way, going 6, 7, 8, 9, 10, and then 10 would put me through the portal. Right, so like there's math there. Const portal weight equals. There's gotta be some math here. So I just need to figure out if I'm from level or to level. Okay, so let's just imagine it's 9 and 0, because that's the one that they're actually showing here. So the shortest from 9 to 0 is 1. So from 0 to 9, but that's not true. Oh, geez, how do I do math for this? Do I start adding and moduloing, or? I need to calculate the distance from the numbers to the tops. Distance to portal, and add up both distances to portal and figure that out. Okay, so distance to portal for 9 is 1. Well, it's 0, really. I'm going to try to add these here. Distance to portal, let's put this here. It is... Dang it, which portal, though? Your closest portal. There's math here. This is why I'm hating it. Oof. Whew. Should not have taken this on tonight. Transphobia. The portal, go down from 0. You find yourself on level 9. Where is the thing? So the shortest path between these is not subtracting them. It can be going through the portal. Okay, I'm even trying to think of the brute way of doing this. Like, do I do something 10 times? So let's think of 9 and 0. So if I do plus 1, that'll put me at 1. 1? Well, 9 plus 0. Well, 9 plus 1 will put me at 0. 0 plus will put me at... So if I just loop through it 10 times and find the minimum distance, adding and moduloing both, we can try that. Let weight equals this. For let c equals 0, c less than 10, c plus plus. And we won't start at 0, we'll start at 1, which means it'll be less than or equal to 10. Const and from equals from plus c modulo 10. Alright, so let me see. 9 modulo 10. 10 modulo 10 will put me at 0. Good. From level const n2 equals 2 level plus c modulo 10. And then if const dist equals math abs, keep subtracting them. Now if this is less than math.min, let's see if this works. Should have no impact on my existing stuff because I don't use portal technology, but this one, when's it? Son of a. Okay, I actually probably need to look and find the portal usage here. That would help me a lot. Not seeing a lot of portal usage here. Wouldn't it be down by 4? No, it'd be 5. It's all equal. 0 plus 2 negative 4. I see. There could be portal travel there. Okay, I just need to see if this ever happens once in its freaking life. If dist less than wait. Come on. Equals dist. I just need to see if this ever actually happens. So if it doesn't, then I've done something wrong. So let's look at all of them. Nope, that's a bad sign. It's a bad sign. That's a bad sign. Okay, let me force portal travel into this example. Example 3. So let's just snap those between 0s and 9s. So we're already going from 0. So let's go to 9. Let's go to 0, then to 9, then to 0, then to 9. So they're all basically one apart from each other. So I'd expect, instead of this being 1, 2, 3, 4, 5, 6, 12? Sounds too easy. But it's definitely just not 6. 38. No. Portal travel. Not happening. Very sad. Okay, let me at least get in there so I can see the path that was chosen and then vehemently disagree with it. Come on. Yep, much disagreements. So yeah, this isn't doing its thing. I guess I need to get in here and look at what's the order operations on this. I bet that's what's wrong. There we go. Hey, okay, let's see about this. Finally, whew. Much larger maze. Oh, just do it again. Well, I can do that. Not too uncommon for these part 2s. No more example, just do it again, but bigger. Don't explode computer. I really appreciate it. This is probably where not using Dijkstra's would eat you alive. Let's do this. That's a number. Please be right. Hey, okay. Center is a special portal on level 0, marked as E. Start from any S, but which starting will allow you to start as fast as possible. Oh, so it's just multiple start points? Oh, okay, so that's just trying all of them? I mean, sure, it's a lot, but is it not just trying all of them? I don't see how this is not just trying all of them, but I got an example, so let's do this. And they say for this one it is 14. Let's do that. You're saying I'll call you 3. not 4, 3. There we go. Solve quest 3. Might as well grab my new input. Yep, that's a lot of input. Look at all them hex codes. They're not real. Okay, yeah, so I'm just same thing, but multiple start positions. I try them all. I find the best. So I'm just gonna copy this. Boop, boop, boop. Solve quest 3. The start is literally any edge, so I'll just say starts and be like, hey, you need to add some. There we go. Look at that. Another start. And then for const start of starts. And then I just keep the best one. This is a more efficient way of this, I know. Const est. I'm trying to think if it would be easier if I were to just invert this and I say, hey, I'm starting at E and my destination is literally any of the edges. Could I do that with Dijkstra's? Be just like, hey, just make it to the end node, buddy. And what's termination, though? Well, what oh, I just collect them. Okay, so this would work. I would just need to then look at all the distances, find the one that's the shortest, choose that. Yeah, it's gonna maybe take longer to rewrite that than this. There we go for start of start. And then will be best equals math.min. Best distance to end, return best. So that needs to be a let. Might be a little computationally expensive, but I think it'll do the trick, and I just need to get my butt down there to part 3 land. Boom. Don't eat my computer. Yeah, I know there are a lot more of them, but yeah, it would be more efficient to invert this. Yeah, let's do that. Let's get a reload going, and let's just get a manual run on this. Let's take all these, I guess. Yeah, I think inverting it is going to be the move. But I'll get there momentarily. I'll at least give this one a chance to run its race. Go console log solve quest 3 backticks paste and off to the races. Get my terminal in there. CD 2024 CD 13 pxts xq. Go for it. Oh, this is a bigger maze and ooh, look at that console log so long in there. Get rid of that. Yes, I'm fairly confident that's not going to go anywhere. I'm glad I grabbed that out. Oh, come on. Okay, so I just want the distances from the start, which is the end. And I'll just be like, hey, where's the best? There we go, we have our distances. We don't want previous nodes. Well, we can get the path to each one if we cared about it, but we don't. and then distances to every start position. So this is where we're going to do the loops. We're going to say const dist to start equals distances start r plus my pipe plus start c best equals math.min best dist to start. Yeah, let's give that one a shot. Still think it's going to be a run, unfortunately, in Jest land. Runs into the example. I'm confident. It's still a big run for this, but we saw that already. Drop of this. Previous nodes. I mean, we didn't need it for any of them, really. That's a number. Boom. Got it. Okay, that was it. Me not seeing portals and floors definitely didn't help. Me not reinventing Dijkstra's definitely did help, so it all balanced out at the end. So I believe these are all correct answers. I haven't put the number in. I didn't break it. Let's get that in there. What's this broken? Nope. Okay, I think we're all fixed now. Plus, got that console log in there, but it's good. That is our initial 13 solution. Now, we got the walkthrough. So, I'm not going to explain what Dijkstra's algorithm is. You can find many other people to do it better. But we were basically given a challenge of you need to find the path through this maze that takes the least amount of time. The time is directly tied to the difference in levels or the difference in numbers. So it takes 1 second to change between all platforms. That's baked in. But it also takes 1 second to move your platform to the elevation of a platform you're walking onto. Now the start and the end are zeros. They're on level 0. The hashtags are walls. You can't touch them. And everything else is a platform of that height. So if you start on 0, well, you have to first wait 5 seconds for your platform to go from 0 to 5. So that's 5 seconds. And then you wait 1 more second because you have to walk from your 5 to the other 5. And then you're here. And now that same check goes on for all of them. So you can go straight, but that's going to cost you 6 seconds in total. 5 because you got to go from 5, 4, 3, 2, 0, 2, 1, and 0. And then once you're at 0, you can walk through, and as you can see, that's why this one's 36 seconds. This one's 30 seconds because there are less, it just takes less time to do it. 28 takes the least amount of time despite being the most amount of changes, or the most amount of walking, because you do the least amount of waiting. That is a classic, relatively classic Dijkstra's algorithm. Weighted edges, find the shortest path possible. The trick is that you can teleport through the platforms, which I didn't anticipate. I didn't read it, so if you are, I'll go through an example I wrote. Here's an example I wrote, where the path for this one is 12, because you are going straight, despite it being a bunch of 9s and 0s. So usually you'd be like, okay, I'm going from my 0, I gotta go all the way up to 9, that's 9, and then 10 to move the extra 1. So you're like, okay, 10, 20, 30, 40, 50, 60, big numbers. That's not how it works. There's a portal in the roof and the floor. So to go from 0 to 9, I make a change of 1. So I'm at 0, and I just go down a floor, and I end up at floor 9. So 1 to move, well, 1 to change level, 1 to move to the next 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which is why it's literally double this one, which was just walk forward, buddy. There's no platforms to adjust. That's what I was missing primarily. I believe part 2 was just bigger maze. Maze bigger. Their example had some spaces in here. They didn't need to be handled differently. And boom, bigger maze. Part 3 is where it got fancy, where it says you can start from any position, but you need to end at the middle. Since I was already using Dijkstra's to do this, I inverted it. But the manual way, if you really wanted to do it, would be to literally start at any position and be like, okay, what's my path, shortest path to the end? That will include a lot of exploration of other paths, and then it'll be the same again. Okay, for the one right beside the one I just tried, what's its shortest path to the end? And that would work. But the inversion is easier because part of Dijkstra's is calculating the shortest distance or path, or at least time, or whatever your unit of weights are, is to any other node. So as part of the exploration of just trying to get anywhere, because the Dijkstra's I grabbed does not have an ending destination, it's just get to all the places. It looks at all of them, and it's like, well, for this one it took me 7, but for this one it took me 8, took me 24, took me all of those. So generating all those distances and then simply looping through them and being like, who did the end get to first? So essentially inverting it to saying, well, for Dijkstra's purposes, this is the start, and all of your ends, who was reached first? And that is what I did. Now, lots of optimization, lots of cleanup, and that is what I will do now. So let's ditch that, ditch the path a bit, because as nice as it wasn't necessary for my needs. Ditch the previous nodes. It's so long since I've implemented an actual Dijkstra. Is there anything else I want to keep from here? No, I might add a condition to this and more incorporate it, but I think it's good where we're at. Yeah, and it's possible for me to have done the Dijkstra and like during this traversal of the world and stuff. It's at the cost of memory, just giving them single responsibilities, a bit easier to do. But there's a lot of repetition there, so I can see that functionalizing really quick. Okay, so I like all of these. These are all great. I'm going to get rid of these comments. They're not useful anymore. Let's make sure all these still work. 9.6 seconds. Yeah, I'll keep away from that one. Go to test. I'm going to skip you for now. I believe you work. I'm just... Yeah, I never actually had a discrepancy between the example and the note, so for timing's sake, we go fast. So all this parsing, boom, function. All this, mostly function. I think what I can do, well, first I can drop this entries call. I believe what I can do is make this particular Dijkstra implementation have an end condition. It's like stop looking when you find it. And that will allow it to end early and allow me to find just the one that I want. The thing here is that usually this has a primary heap, that allows you to do that, but I'm not seeing that here. So what are we pulling from? Unvisited length, you just pick. Oh, this is how you're doing it. Oh, you're not sorting, you're okay, you're just finding the next one. Sure, I've seen worse. That's what I get from just taking stuff off the internet. So yeah, I'm gonna add ending condition of a target node, which is gonna be right here. And as soon as it meets it, it should stop looking. I'm not gonna see this in 1 or 2. I'll see this in 3. Ooh, and here's the thing. It won't be a singular, it'll be a multiple. So any of these should give up. So it's gonna be interesting. Start stat map S. And then it's basically this. Right. So let's see if I can do this easily. Node string a thingaming. Okay, so once I make it to, once I visit the current node, I visited you. It's been a really long time. So once I have a distance to a visited node, well, the problem with that is Dexter's does really good because it looks at everything. I'm thinking of like, okay, great, if I go down this path and I'm like, hey, I found the end first, but I never looked at this one because it was shorter, like, I think there's a risk that early termination can bite me. But let's say about that. Let's say if distances neighbor, so we're going through all the neighbors, and boom, we found a thing. If end nodes includes neighbor, return distances. So this is basically the early termination. We found one of the ones you were looking for. Not too confident this is going to do what I want. Yeah, we're going to have to or numbered at max, because he might not have gotten to you. Let's see if these don't break, though. Yeah, I felt like that would happen. So it went from 14 to 15, because we're just not looking at all of them. Yeah, that's on me. What I get for trying to invent something that's already been well done. So mainly the main thing we're doing is the parsing. Do I even need the world for this, or just need the graph? I just need the graph, so let's do that. Function parse world notes string. I'm just gonna generate me a cool graph and a start and an end. Well, starts and end. But what the heck that semicolon doing there? That's supposed to be a comma. Starts. No way, I'm just making it compatible. The part ones will obviously never get multiple. Let's go ahead and type all this out while we're here. Record string number. We're also going to turn these into numbers real soon. There we go. Starts. Let's make a type for that. There we go. We have starts, which is a location array. You do that, end is great, everyone's great. Okay, everything's good there. Now we can use that here. So const graph starts, which I can just say start, and then end equals parse world notes. Yeah, part 1 and part 2 should be very happy. Distances, distance to end, just return it there. Perfect, perfect. Do the same for part 3. trailer to go copy those lines, actually. There we go. And then we have all starts, so let's go ahead and keep them. And I mean, best is technically accurate. And it's not distance to start, it's times. Shortest time, which, yeah, I guess shortest time is accurate. And I did do a +1 here, which responsibility, who does it to who, because I had it in the parsing originally, which does make this more complicated. So I'm not going to change too many more things, get this functional, then I'll change it here. That way I can drop that conditional and just be like, hey, it's wherever you're going and an extra for your troubles. There we go, yep. Same way, just makes this a little more pure. The weights have the calculator. Okay, I like it, I like it. We have distances, which is times, time. Just put that right in there while we're here. Okay, I'm pretty happy with this. Let's make sure it all still works. Beautiful. Now I'm gonna do this thing properly. Is the world always a square? It's a great question. I'm just gonna go steal the code from last time. Where'd it go? Calculate chord key. There it is. Which comes from the media parser, which comes from that, which comes from this. There we go. Which I guess I can give it from the world. Sure, this sounds like a good enough place. Whoops, whoops, whoops. Put it in there. Okay, max x, max y, which isn't really that. I mean, they are things. Max x is just world.length. Well, I don't have x and y, I have row and column. Oh, before I do that, let me just rename some other things. R C R C max R max C. Okay, now that I have these defined a little better, I can actually replace them. You know, so we can make variables. We can spend the time. Max R equals world.length -1 maybe. They are thankfully squares, so we have that nicely to deal with. Great, now we have the calculation of the coordinate key. We can use that in places. We could have used that literally above. Hey you, let's get out of here. And we'll still export you, but we want you to do some stuff for us first. There we go, let's head on up. Nice, so nothing's broken yet. Everything's still doing exactly what it was doing before. Now is where we change all the things. So boop boop. Numbers. And TypeScript don't care because we're not doing cool stuff yet. Calculate chord key, RC. Or still we do that. We do it right here. NR and C. Okay, so we're good there. Now we need to do it in the other places, which is right here. Start R, start C, And then right here, ndr_nc. Now this is enough to run part 1 and 2 with. Beautiful. Let's do it for 3. ndr_nc. And whatever start we're dealing with. Loving it. Like a charm. Okay, so this is better. And yeah, this works. I'm happy with it right there. Okay, let's see if we can do a few more polishes. So yeah, if it's a thing, we ignore it. If you're a start, you're a start. If you're an end, you're an end. Yeah, this logic could be encapsulated a little bit. Const car to level equals car string. Boom. And here we go here. Good. All our cardinal directions. This can be constantized. Directions. Spell the word directions correctly. There we go. Love it. 2 level. Yeah, I feel like this could really use some love because it works, but whew, jankiest way possible it feels. We need this key. We need it to create the dictionary or the map and to access it. So, sure. This could be variabilized. Don't see it really worth it though. We can do it right here. Const. And cool. We'll call you times. It's a great name. I don't know. Names are hard. It works. Which now means we just need the key once. Boom. Still need that from level. Still need the other character to do stuff. Just the once though. If you're out of bounds, inbounds. Okay, good. Yeah, this is the part that's got me scratching my head. I assume if I drop this, part 3 dies. Yeah, it does. So I'll put it back. Feels like... Okay, well, maybe we start unskipping the notes one there. Because it might be time to use it as an example now. I forget it actually is a run long. Oh, down to 3 seconds. We're doing good. Still a long run time. Obviously, this isn't the good way of doing it. It is thankfully a relatively one-off thing. This map could be greatly optimized by not generating like a majority of it, because once you go somewhere, you're not allowed to go back. But then for some of the realer examples, like look at this 2x2 of here. It's like, well, where do you consider the entry and where do you consider the exit, right? Like if you're coming in the left, then you'll only be able to go these ways, and then from 4 down to 1, and then from this one back up. Well, if you're coming in from the right, you want the directions, like you'd be able to travel that way. So it's hard to... Doing a pre-generation of all possible edges doesn't really allow for that. It would have to be within the pathfinding, only generating edges for things you haven't been to yet. But we ain't doing that. So as gross as this is, I think it's tight. Can make those a little cleaner though. Well, I hope the operation survived there. It did, nice. And then I can just do math min stuff. Boop. Bop, bop, bop. Loving it. Make sure it all still works. It does. I know extra function calls. The end of the world. 2 level. I do need that. Let's not name it other car. Well, let's name it some good stuff. Car from level. From car. To car. To level. And it's not weight, it is time. From level 2. Yeah, from and to. I like it. Okay, I am pretty happy about that generation. Both of our solve calls. I don't really see many improvements I want to make to this Dijkstra's I grabbed off the internet. Times. Sure. I've seen worse, I've been blown worse. It works. I mean, it's weird having that bit there, so let's have that all generated. Yeah, generate times, why don't you? Visited, unvisited, they just live. Can you make this a set? Oh, one of these a set. Yeah, you can just make this one a set. I don't know why this isn't a set. I'm gonna make it a set. Wait, do we literally not use visited for anything else? What's the point? Why jump? It's not being used. Like 5 seconds. We good. Nice, let's save us some memory. Unvisited, all of these. Just go through them, remove the one that we're picking. Right, because we're not doing a heap sort or anything. We're just ripping it off. I wonder how much better it would be with a sort. Not here to improve that. For all the ones, if less than, then assign it. Can I just do a math thing here? I'm just gonna do a math thing here. Yes, it's a function call. Function calls are expensive, but that's what you're doing. Well, that's what's being done here. Yeah. I like it better for neighbor and graph. Current node. Just call it node. Oh, can't call it node because I'm doing that node. Let's go ahead and give this at least a type. Woo! Start node, a number. Yeah, we'll just name you a start there, buddy. Shortest time. Do we need this for anything but finding this? We don't. That's called a call to find. Const node equals unvisited dot find node times. Well, it's not really a find. It's a reduce, I guess. Reduce. Next node. Node. Oh yeah, I guess I'll put the if conditional in there. Kind of regretting my reduce because it got a little fancy. Times next node less than times node. I think I've done this backward. The node for the one I found is the one then we have found for the next one. Then return mine, else return next node, yours. Drop all that. And then, yeah, if we didn't find it, I'm really sorry about that. Yep, as expected. I like this. I'm going to inline it. Boop, 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 boop. Delete, delete. Still 11 it. Might as well smush them together. Unvisited splice. Yep, get rid of the one. It's fine with me. For all the neighbors, find the times. We don't need that. Sure, we'll keep the unvisited keys there. Yep, okay, I'm pretty happy with it now. And yeah, all this inside, still already happy with it. Yeah, that is my optimization. Add that, commit that. And yeah, if there's not much left to walk through, but I'll go through it once more. So for part 1 and part 2, it's identical. First, we generate all, like, a directed graph. This isn't, yeah, it's a directed graph from every position to every other position, with a little bit of parsing here. We go through every row, every column. We find the ones that are alphanumeric characters or numeric characters, basically ignoring walls and spaces. We don't care about walls or spaces. We cannot go to them. If we happen to find the starts or the ends, we keep track of all the starts, our singular end. We convert the character to its level, which, if it's a number, is just its number. If it's not a number, then it's the start or the end, which have a level or a height of 0. Then we generate the other half of the graph for, okay, so you're going from this key to what keys, and this will eventually have mappings of how long it takes you to get to those other platform coordinates. Speaking of those, we look in all 4 cardinal directions. If we accidentally walked off of the world, or we're going somewhere we don't care about, which is a wall or the edge of space, don't look at it. Otherwise, we generate the level, or we parse out the level for that character, and we figure out what time it will minimally take, which, if there weren't portals, would just be this call here. But since we're thinking with portals here, we're also considering all of the other possibilities, which this is the laziest mathematical way to do so. And now that I'm looking at this, we're going to be even lazier. We're going to put this in here to let the loop calculate that initial one, which still works like a chime, yeah? So, it just says, okay, wherever level you are, you're all just going to wrap around just so that we get every possible distance between you two. Again, not the most optimal way of doing this, but it's okay. Then we record the time it takes to get from your from character to your to character. And we say, well, that takes however much time we calculated, plus 1. That plus 1 being the cost of actually moving between any position whatsoever. So we do that, we return the graph, all our start positions, our end position, and the little function that helps you calculate the key for the coordinate using 2-dimensional integer math tricks. For part 1, we just send that through Dijkstra's algorithm, and we say, hey, you're starting at the start, because there's only one start. I already said I wasn't going to explain Dijkstra's, but we keep a track of the time it takes to get to every node. We say the time it takes to get to the start node is 0, because that's where we started. And then we look through all the nodes we have yet to visit. We find the one that we can has the least amount of time to get to, which for the initial run is going to be this one. It's going to be our start node, but we always go for the next shortest path. We get rid of it. We say we have visited it. Do not consider it unvisited no more. And then we go through all of our neighbors, and we're saying, hey, the time it gets to the neighbor, it's either the time we've already been to that neighbor, or it's the time it takes to go from where I'm at to my new neighbor, or to this neighbor, whichever is smallest. Because we can discover a path to one and then later go on a longer journey or a shorter journey and rediscover a different path to that one. We just care about the shortest one. Then we return that mapping of here's how long it took for me to get to every possible position in the universe. Then from that, you calculate, well, how long did it take me to get to my end coordinate? And that's how long it took you to get to the end. Again, we're not keeping the pathing information, we're just keeping the timing information. Quest 3, exact same thing, but instead, we say we start where the end label is, which just allows you to basically branch out from there. And since it's Dijkstra's and we don't have an end condition, it just goes through every possible node, building a giant dictionary and hash map of how long it took me to get to literally anything, including all of our start positions. Then we go through every start position and we're like, hey, how long did it take to get to you? Are you shorter than the last one I saw? Okay, you're winning. And then we just go through all of these. We figure out which one took the least amount of time with a math.min. And we return the one who was the quickest, or the shortest. That's really the word quickest, isn't it? Yeah, it is. Do I have another word of shortest somewhere? I don't. Okay, thankfully not. So yeah, that is that for the solution walkthrough. As I was walking through Unvisited, I was tempted to turn this into a set. Would mean I need to undo my reduce, but that wouldn't be the worst in the world. Because it allowed this removal to be easy. Well, no, it'd be a set. Yeah, let's go for a set. Just because I want to. There we go. Let node equals null. Well, yeah, for const other node of unvisited. If not node equals other node. If times, and this is where I'm just going to steal this code. Oop. Node equals other node. Or, yeah, I guess I swapped these around a bit. Node is the one I found. Other node is the challenger. Boop, we do that. Now we can do unvisited remove node. Is it not remove? Is it delete? It's delete. Apologies. Yeah, and I think we can just swap this in here. If you haven't found one, or if the one you're looking at is quicker than mine, you win. The main optimization here is that splice. It was expensive if it's the first in your list, where blah blah blah. Now it's less expensive. Still the same computational for my unwrapped reduce here. But yeah, we have optimized it further. But yeah, that is the problem. Hopefully that it has been a pleasure.